Welcome back. So let's review some basics before we start today. What finance is about again? P0. Finance is about P0, right? P0 is what? P0 is D, right? And D of what? D of future benefits, right? Right? Or payoffs, right? Future benefits or payoffs, right? Benefits or payoffs. And D is about a couple of elements, right? T and R, right? And R is what? Return. R is return, right? And return is what? It's RF, right? That's the risk-free return, right? Plus what? Plus what? Plus a risk premium. Plus what? Plus a risk premium. And how much is the risk premium? How much is it? This is what? This is the quantity of risk, which is what? Which is beta, times what? Times the market price of risk, which is what? Which is RPM. Which is what? Which is RPM. Again, how much is RPM? How much is RPM? How much is RPM? RPM is what? It's RM minus RF, right? And this much we refer to as the market risk premium. You got it? And this much we refer to as what? The market risk premium. You got it? So this is pretty much what we do in finance. This is what finance is all about. It's P0, P0 is D, and D is T and R. T is time, no sweat. R is return. And how we model R, how we explain R, we explain R in terms of the risk-free return in addition to a risk premium, right? And the risk premium is going to be what? Is going to be the quantity of risk. The risk premium is how much we pay for risk, right? And how much we pay for anything, it's nothing but the quantity times what? Times the price, right? The quantity of risk is going to be what? Is going to be beta. And the price for risk, the market price of risk, is a RPM, which is what we refer to as the market risk premium, and define it as RM minus what? Minus RF. RM minus what? Minus RF, right? Now, what is beta again? What is beta again? What is beta again? It's what? It's the non-diversifiable risk. It's what? It's the non-diversifiable risk. It is what? It is non-diversifiable. It is non-what? It is non-diversifiable. And you know why, right? So beta is non-diversifiable risk quantity, and you know why? You got it? So beta is non-diversifiable, and you know why? Because why? Why beta is non-diversifiable? Because this much is what diversified investors worry about. And why we have to worry about diversified investors? Because those investors are going to be eventually ending up with all the assets in the market. Right? Why? Because they're always going to be in a position to offer nicer for those assets, right? So that's why, right? Good. So beta is what matters for us. So beta is what matters for us, but beta is one component to risk, right? It's what? It's one component to risk. It is not all of risk, right? So beta is just like a part of the risk. Right? It is not all of risk. It is not what? It is not all of risk. It is not total risk. Beta is not total risk. It is not what? Beta is not total risk. Beta is a part of it. Beta is what? Beta is the non-diversifiable part of total risk. It is the non-diversifiable component of total risk, right? All right. So how we see total risk? How we see total risk? Let's see here. So how we think of total risk in finance? So how we think of risk in finance? So we think of risk in terms of a couple of components. In terms of what? In terms of a couple of components, right? In terms of a couple of components. First we have the diversifiable component, which is what? Which is firm specific. Which is what? Which is idiosyncratic, right? Right? The other component is what? The second component, or the other component is what? Is non-diversifiable, which is what? Which is beta. Which is what? Which is beta, right? Which is what? Which is beta. So we have risk is made up of a couple of components. The diversifiable component, which we refer to as firm specific or idiosyncratic, and the non-diversifiable component, which we refer to as what? Which we refer to as beta, right? And what matters for us? What matters for us is here. What matters for us is beta. What matters for us is what? Is beta. But beta is not total risk, right? Because there is more to total risk than just beta, right? There is more to total risk than just what? Than just beta. There is more to total risk than just beta, because total risk has also what? Has also the diversifiable part. Has also what? Has also the diversifiable part, right? How we think of total risk in finance? How we think of total risk in finance? What defines total risk in finance, right? Risk in finance is defined in very simple terms. Risk in finance is defined in very, very simple terms. In fact, it is nothing but 3 words. It is nothing but 3 words. Risk in finance is all about time-varying returns. So what's risk in finance? Time-varying R. What's risk in finance? Time-varying R. What's risk in finance? Time-varying R. So what's risk in finance? It's R that varies across time. So what? It's R that varies across what? That varies across time. What's risk in finance? It's time-varying R. What's risk in finance? Time-varying R. So how we think of risk in finance? How we think of risk in finance? We think of risk in finance in terms of nothing but the time variability of R. In terms of nothing but what? By the time, but what? But the time variability of R. You got it? So what's risk in finance? It's time varying R. What's risk in finance again? It's time varying R. So again, what's risk? It's time. It's what? It's time varying R. Right? So what's risk in finance? It's time varying R. What's risk in finance again? It's time varying R. We refer to it also as volatility. We refer to it as what? As volatility. We refer to it as what? As volatility. As what? As volatility. So what's risk in finance? It's volatility, i.e. what? I.e. time varying R. I.e. what? I.e. time varying R. So this is referred to as volatility, right? This is referred to as volatility, but it's volatility as in the standard deviation of returns. As if what? As if the standard deviation of returns. So what do I mean by risk in finance? What do I mean by risk in finance? How can we define it? It's time varying R. It's what? Time varying R. How we measure it? It's volatility as in what? As in the standard deviation of return. You got it? So it's volatility as in what? As in the standard deviation of return. As in what? As in the standard deviation of return. Let me explain a little why we need the standard deviation. Why we need the standard deviation in return. Why you have to worry about measuring the standard deviation of return. Why? Why the standard deviation of return happens to be so paramount as far as like financial risk is concerned. All right. Well, we're here. Why we need risk in the first place? We need risk because of what? Because of R, right? And why we need R? Because of what? Because of D. And why we need D? Because of what? You see that? So please keep your eyes on the big picture. You got it? Keep your eyes on the big picture. You got it? Why we need risk? Why we need risk? Because of R. Why we need R? Because of D. Why we need D? Because of P0. Because of what? Because of P0. Good. But what matters for R is not total risk. Is not what? Is not total risk. It's a part of it. It's the non-diversifiable part of it, which is what? Which is beta. But how much is total risk? How much is what? How much is total risk? Total risk turns out to be nothing but the standard deviation of return, which we refer to as what? Which we refer to as the volatility. Which we refer to as what? Which we refer to as volatility, and define it in terms of what? And define it in terms of time varying returns, right? And define it in terms of time varying return. All right. Why do I have to worry about the standard deviation return? Okay, good. How can we describe R? How can we describe R? Well, first, R is a variable, right? R is a variable because it can apply to any asset. It can apply to any investment opportunity, and therefore it varies among assets. It varies what? It varies among assets. It varies among investment opportunities, and therefore it's what? And therefore it's a variable. And therefore it's what? It's a variable. So first, R is what? R is a variable. R is what? R is a variable. Why R is a variable? Why R is a variable? Because it's asset specific. Because it's what? Because it's asset specific, right? It applies individually. It applies what? It applies individually to what? To different assets, right? To different assets. So if Majid is an asset, right? If Abdullah Suruji is an asset, right? I'm going to be investing in both assets. I'm going to be having what? I'm going to be having different returns. I'm going to be having what? I'm going to be having different returns, right? Therefore, the return, R itself is what? R itself is a variable because what? Because it's an asset-specific concept. Because it's what? Because it's an asset-specific concept, right? Right? So R is a variable. R is what? R is a variable. So how we think of R? We basically think of R the same way we think of any variable. You got it? The same way we think of any variable. All right, what kind of variable is R? What kind of variable is R? What kind of variable is R? Well, the big question in finance is about what? Is about the future. Is about what? Is about the future. So I invest now, but I don't know how much return I'm going to be getting, right? You see what I'm driving at? So I invest now, and this is why I'm solving for P0, right? This is why I'm solving for P0, because my investment problem has to be solved now, right? My investment decision has to be made now, right? That's why I'm solving for P0. So I'm investing now, right? I'm investing now, but I don't know how much return I'm going to be realizing. I have to expect it. I have to what? I have to expect it because it's all about the future, which I don't know, right? Which I don't know because I'm still now. Because I'm what? Because I'm still now, right? So R is a variable, but I don't know it, and therefore it's a what? It's a random variable. It's what? You see what I'm driving at? So R is a variable. Why? Because it varies among assets. It varies among what? It varies among assets, right? Right? For every asset, there is a particular R. For every asset, there is what? There is a particular R. But I don't know it yet. I don't know it yet because I'm about now, and R is still somehow to be realized what? To be realized in the future. You got it? So R is not just any variable. R is a random variable because I don't know it. R is what? R is a random variable because I don't know it, right? How we think of a random variable? How we think of a random variable? How can we define a random variable in general? A random variable is any variable for which you know the possibilities, but you don't know the outcome. You got it? So what's a random variable? Please, and this is a very, very important concept in finance. I hope you're not going to be missing it. I hope you're not going to be missing it. R is a random variable. R is a random variable. First, why is it a variable? Why is it considered a variable? Because it varies among assets. For every asset, there is an R. You got it? And therefore, it's a variable. Therefore, it's what? Therefore, it's a variable. Second, it's a random variable. Well, it varies among assets and among periods as well. You got it? You see that? So it's a variable, right? It varies, and therefore, it's a variable. It varies among assets. Right, in the cross-section, it varies among assets in the cross-section, and it varies between periods in the time series. You got it? You got it? So if you think of R over time, it's also going to be a variable. It's also going to be what? It's also going to be a variable. If you think of R in the cross-section of investments, of investment opportunities, if you think of R in terms of the cross-section of assets, it's also going to be a variable. So again, whether you take it cross-sectionally or time serially, right? Whether you take it cross-sectionally or time serially, it's going to be what? It's going to be a variable. It's going to be considered a variable. You got it? Good. So it is not just any variable. It's a random variable, right? It's a random variable. Why? Because I'm solving my problem now. I'm solving my investment problem now. I'm making my investment decision now. But I'm still going to be realizing R sometime in the future. And therefore, I don't know it as of now. I don't know it as of now. And therefore, it's random. And therefore, it's what? And therefore, it's random. So what I'm trying to tell you here is that we're going to be analyzing R the same way we analyze a random variable. You got it? So we're going to be analyzing R the same way we analyze a random variable. And how we analyze a random variable? Well, before we answer this question, let's go ahead and answer what do I mean by a random variable. And what do I mean exactly by a random variable? A random variable is any variable for which you know the possibilities, but you don't know the outcome. You got it? Good. So think of your grade in this course. Think of your grade in this course. The possibilities is somewhere between 0 and 20. You got it? The possibilities is somewhere between what? Somewhere between 0 and 20. But you don't know which possibility you're gonna be getting, right? You don't know which possibility, you don't know which outcome you're gonna be getting by the end of the course, right? But you know the possibilities. You know your bets, but you don't know which outcome. You got it? And therefore your grade in this course is a random variable. You see what I'm driving at? So why your grade in this course is considered a random variable? Because you know the possibilities, but you don't know the outcome. Now, if only integers are allowed for the possibilities, if only integers are allowed, so you know the possibilities, somewhere between 0 and 20, you can count the possibilities because we're going to be talking about what? We're going to be talking about 21 possibilities, right? Only whole numbers, right? But you still don't know the outcome. So if you know the possibilities, you can count them, but you still don't know the outcome, right? Right? This is what we refer to as a discrete random variable. This is what we refer to as what? A discrete random variable. A discrete random variable. You got it? So what if everything is allowed between 0 and 20? Now you know the possibilities. It's going to be somewhere between 0 and 20. Can we count everything between 0 and 20?
Yes.
No, everything between 0 and 20 cannot be counted. Right? How many numbers are there between 0 and 20? An infinity of numbers, an infinity of possibilities. So if everything is allowed between 0 and 20, right, you cannot count the possibilities. You cannot what? You cannot count the possibilities, right? This is as opposed to allowing only integers, right? If integers were only allowed, you can count the possibilities. You're going to be having 21 possibilities for the grade, right? You're going to be having 21 possibilities for the score. But now, if everything is allowed, you cannot count the possibilities. Whenever you cannot count the possibilities, whenever the possibilities are uncountable, this is what we refer to as a continuous random variable. This is what we refer to as what? A continuous random variable. All right. So let me here explain. Okay, here. So R is going to be what? R is a random variable. R is what? R is an RV. R is a random variable. What's a random variable? What's a random variable? What's a random variable? It's known possibilities. It's what? It's known possibilities. It's known possibilities, but not the outcome. It's known possibilities, but not what? But not the outcome, right? So what's an RV? An RV is all about knowing the possibilities, but not the outcome, right? Right? Now, if possibilities are countable, if we can count the possibilities, if we can count the possibilities, what are we going to be answering to? We're going to be answering to a discrete random variable. We're going to be answering to what? To a discrete RV. To what? To a discrete RV, right? If the possibilities are uncountable, okay, so if the possibilities are uncountable, what are we going to be answering to? We're going to be answering to a continuous random variable. We're going to be answering to what? A continuous RV. Okay? What are we going to be answering to? We're going to be answering to a continuous RV. Good. Your grade in this course is it considered a discrete RV or a continuous RV? Well, this college only allows integers. This college only allows for what? Only allows for integers. And therefore, your grade in this course is what? Is a discrete RV because we can count the possibilities. You got it? So we know the possibilities, we can count them, but we don't know the outcome. You got it? And therefore, your grade in this course is what? Is a discrete RV, right? But we don't study your grade in this course in finance. We don't. The subject matter of finance is not the grade, is not your grade in this course. The subject matter of finance is R. And therefore, the relevant question to ask here is about R. Are we going to be considering R a discrete RV or a continuous RV? And the answer, R is a continuous RV. R is a continuous RV. So unlike your grade in this course, which is a discrete RV, right? Why? Because this college allows for integers, right? This college only allows for integers, and therefore your grade in this course is going to be a discrete RV. R is a continuous RV. R is what? R is a continuous RV. Good. So in order to explain why R is considered a continuous RV, right? Let's first explain the possibilities for R. What are the possibilities for R? Let's see. So R is going to be always where? R is going to be always where? Let's consider the possibilities for R. R is always going to be where? R is always going to be where? So your grade in this course, is always going to be between 0 and 20, but only integers are allowed. But only what? But only integers are allowed. And this is exactly why we're going to be thinking of it the same way we think of a discrete RV, right? R, I'm telling you, R is a continuous RV. But before we get there, before we can go home with this much conclusion, right? What are the possibilities for R? That's my question. What are the possibilities for R? Well, R is always going to be here. R is always going to be here. And this is a very strong statement in investments and finance. This is a very profound statement in investments and finance. R is always going to be here. So it's going to be bounded from below by -1, but it's not going to be bounded from above. You got it? Okay, so before I explain why this is so, before I explain why this statement is correct, can we count the possibilities here? Huh? Do you know how many possibilities are there? Of course we can't, right? Of course we can't. And therefore R is what? R is a continuous RV. You got it? So why R is a continuous RV? Because R is somewhere here, right? But here we can never count the possibilities. The possibilities are simply infinity. There is an infinity of possibilities here, and therefore we cannot count all the possibilities, and therefore what? And therefore R is continuous. R is what? R is continuous. So we know now that R is a continuous RV. But why R is here? Why R is always going to be here? The way to think of a -1, is a -100%. Is what? Is a -100%, right? The most you can lose is what? Is 100%. The most you can lose is what? 100%. Is 100%. And therefore, the lowest number R can take is what? Is -1. You see what I'm driving at? Yes. The lowest possibility for R is what? Is -1. Why? Because the most you can lose is what? Is 100%. The most you can lose is what? Is 100%. And therefore, the lowest possibility for R is always going to be what? Is always going to be -100%, i.e. -1. I.e. what? I.e. -1, right? But the most you can gain is what? It's infinity. It's unbounded. It's unbounded, right? Again, this is a very profound statement in finance and investments because investments is good. Okay, finance and investments. Investments is good because it's bounded from below, right? It's about there is a specific much as to how much you can lose, right? There is a lower bound as to how much you can lose, right? But how much you can gain is unbounded, right? How much you can gain is totally unbounded, and therefore, if you do the right things, right? If you do the job correctly, right? Your gain is somehow unbounded, right? Your gain can fetch up to infinity pretty easy. You got it? Right? And your loss is bounded, right? Your loss is what? Your loss is bounded, and therefore the potential for gaining is far more larger. It's far what? It's far much larger. The potential for gaining in investments is what? Is far much larger because it is not bounded. It is not bounded from above. The gain is not bounded. The loss is bounded. I hope this is clear. You got it? So investments is a good thing. If you're thinking about investing, go ahead. Go for it. But be careful. Be careful. Just make sure you're doing the right thing. Make sure you're doing the right analysis. And things most likely will pay off. Things most likely will pay off. Right? So we should be somehow like proactively positive about investing. We should be again proactively. We should be like somehow proactively positive about investing, about investments. Why? Because the potential for gain is much larger, right? The gain itself is unbounded, and this is totally unlike the loss, which is what? Which is bounded. Which is what? Which is bounded. So R is not bounded from above, but bounded from below. But bounded from below, and therefore the potential for gain is much larger. And this is a very nice statement in favor of investments. In favor of what? In favor of investments. So if someone dislikes investments, right, I'll just have to explain to him this statement, and I'll have him most likely convinced. You got it? I'll have him most likely convinced. I hope you see it, right? I hope you appreciate it, and I hope you see the significance of it, right? I hope you see the significance of it. The lesson of today is that we're going to be thinking of R the same way we think of an RV. In particular, the same way we think of a continuous RV. You got it? So we're going to be thinking of R the same way we think of what? The same way we think of a continuous RV. You got it? Good. And how we think of a continuous RV? Again, RV is, we don't know the outcome, and if you don't know something, you have to do what? You have to expect it. You have to what? You have to expect it, right? So speaking of your grade in this course, you don't know it, but you can expect it, right? So Mansoor can expect, for example, 15 out of 20 as far as like his grade in this course is concerned, right? Right? Bara can expect 14 out of 20, right? Abdullah can expect like 17 out of 20. Again, Abdullah, Bara, Mansoor do not know of their grades, but they can what? They can expect it. They can what? They can expect it. So if you don't know the outcome, the best you can do is what? Is to go ahead and expect it. And go ahead and what? To go ahead and expect it, right? Right? To go ahead and what? To go ahead and expect it. To go ahead and solve a most likely problem. To go ahead and solve what? A most likely problem, okay? Because your expected grade is going to be more or less your most likely grade. It's going to be what? Your most likely grade. You got it? So how we're going to be thinking of R from now on? We're going to be thinking of R in terms of what? In terms of the expected value. In terms of what? In terms of the expected value. In terms of probability. In terms of what? In terms of probability. In terms of what? In terms of probability. We don't know the outcome, and therefore the best we can do is to become probabilistic about it. Is to become what? Is to become probabilistic about it. Again, we don't know the outcome, and therefore the best we can do is to do what? The best we can do is to become probabilistic about it. Is to become what? Is to become probabilistic about it, right? So again, R is a continuous RV, and how are we going to be describing it? We're going to be describing it probabilistically. We're going to be describing it what? We're going to be describing it probabilistically. We're going to be describing it what? Probabilistically. Good. So describing R. So describing R is going to be what? Our description of R is going to be what? Is going to be probabilistic. Is going to be what, huh? Is going to be probabilistic. Why our description of R is going to be probabilistic? Because R is an RV. Because what, huh? Because R is a random variable. Because what, huh? Because R is a random variable, right? Any probabilistic description on a most basic level, covers a couple of measures. Covers what, huh? Covers a couple of measures. You got it? So any probabilistic description, any what, huh? Any probabilistic description on a most basic level covers what, huh? Covers a couple of measures. Covers what, huh? Covers a couple of measures. So again, describing R, and the key here is to what, huh? And the key here is what, huh? The key here is to what, huh? Is to go ahead and employ probability. Is to go ahead and employ what, huh? Employ probability. You got it? Probability. Is to go ahead and employ probability. Okay. So any probabilistic description is most basically about a couple of measures. Is most basically about a couple of measures. The first measure is what we call a most likely measure. Is what we call what, huh? A most likely measure. The second measure is what we call how far. How far on average. How far on what, huh? On average. So how are we going to be describing R? We're going to be describing R with a couple of measures, right? The first measure is what we refer to as a most likely measure. We don't know the outcome, so we have to what? We have to think in terms of the most likely outcome. The most likely what, huh? The most likely outcome, right? Right? And if you sort of like conceptualized your most likely outcome, right? You have to know, or you better be knowing, how far on average you're going to be from that most likely outcome. You see that? You see that? So a probabilistic description is about what? Is about a couple of measures. The first measure is what? Is a most likely measure. You don't know the outcome, so we're going to be after what? We're going to be after the most likely outcome. And the second measure is about what? Is about how far on average we're going to be from that most likely outcome. From that what? From that most likely outcome. The most likely outcome is what we call the expected value of R. Is what we call what, huh? Is what we call the expected value of R. Is what we call what, huh? Is what we call the expected value of R. And how far on average? How far on average is what we refer to as what? Is what we refer to as, huh? Is what we refer to as what? Is what we refer to as the variance of R. Is what we refer to as what, huh? Var R, or the variance of R. You got it? Is what we refer to as what, huh? Var R, or the variance of R. The variance of R. Well, let me say it's going to be what? It's going to be the square root. It's going to be the square root of the variance of R. So this is going to be raised to the power of 1/2. So all right, let me just let me go this far. Let me go this far. Again, so R is ought to be described probabilistically. Why? Because R is an RV. You got it? R is ought to be described what? Huh? R is ought to be described probabilistically because R is what? Huh? Is an RV. How are we going to be probabilistically describing R? With a couple of measures, right? A most likely measure and what? Huh? And how far on average measure, right? Right? The most likely measure is what? We don't know the outcome, so we're going to be thinking in terms of the most likely outcome. The second measure has to do with what? Has to do with how far are we on average from that most likely measure, right? From that most likely value, right? The most likely value is what we refer to as the expected value of R, right? And how far on average we're going to be from that expected value of R is how we define in terms of the square root of var R, the square root of the variance of R. So let me go ahead and define the expected value of R and the variance of R, and we continue. Okay, so the expected value of R We're going to be applying those concepts to real investment problems in just like few minutes. Over the course of the coming few minutes, we're going to be applying those concepts to real investment problems, and therefore you don't have to worry much about the mathematics. But the expected value of R is what? The expected value of mathematics is a sum. It's the summation of Ri, Pi, as I goes from 1 to n, such that Pi is here. Pi is always here. And the summation of Pi as I goes from 1 to n is 1. And those two statements together is what I refer to as the law of what? The law of what? The law of probability. The law of what? The law of probability. Think about it. Any probability is a number between 0 and 1, right? Right? And the summation of all probabilities is what? The summation of all probabilities is what? Is 1. You got it? The summation of all probabilities is what? Is 1, right? And therefore the expected value is about the law of probability. We're going to be summing across n such that the law of probability is going to always apply. Let's see an example. Because you guys are kind of lost. So let's see an example. So page page 122, the first problem. Page 122, the first problem. What we have? So page 122, the first problem, what we have? We have Ri and Pi, right? You have returns and probabilities, right? This problem, the first problem. Yeah, page 121, the first problem. What we have? We have R, right? We have what? We have R and P, right? We have returns and probabilities. We have what? We have returns and probabilities. So now tell me what are the returns? We have what? The first return is what? The first return is negative 10%, right? The probability was how much? The probability was how much, Mansoor?
The first question here or where?
Page 122.
22.
Here. The first return was how much? Negative 10%. The first probability was how much?
0.1.
Was 10%. You got it? You got it? Right? So negative 10% for Ri. How much is Pi? The probability is 0.1, which is what? Which is 10%. The second Ri is how much?
0.
The second Ri is what?
5%.
The second Ri. Return. Read the problem correctly, please.
0.
Is 5%.
The second return is 0. Good. Pi is how much?
20%.
20%. Thank you. At least, can you read this much? At least, can you read this much? So Ri is how much? The third Ri?
10%.
The third Ri, how much, Mansoor?
10%.
What do you mean by RI here? We have just two choices here. Probability of occurrence and possible return.
So what you think? How much is it? I'm not going to be answering this question. How much is probability?
30%.
What about the fourth Ri? So now you know, Mansoor, what I mean by Ri?
20%.
How much?
20%.
20%.
30%.
How much is it?
30%.
What about,
That's last.
yeah?
30%.
30% RI?
Yes. And 10%.
And what about PI? So now how much is the expected value? The expected value from here was how much? The expected value was how much? What did I do? What did I do? I multiply and add, right? Right? I multiply RI by PI and add over what? Add over N. Add over what? Add over N. So what should I do here?
Negative.
Yes, so the expected value is going to be what? The expected value of R is going to be what? It's going to be what?
Minus
Negative 10% times what? Times negative 10% times what?
10%.
Times 0.1, right?
Yeah.
Plus
0.
plus 0 times 0.2, right? Plus
Plus 10%.
plus
10%.
plus 10%
Times 30. 0.3.
times 0.3 plus
20%.
plus 20%
As well as times 0.3.
times what?
0.3.
Times 0.3 plus
30%.
plus what?
30%.
30%.
0.1 times 0.1.
And the answer is going to be how much? So now you know how much is the expected value? Does it make sense now? Huh?
Yes, it does.
Does it make sense now?
Yes.
Huh?
Now it does.
So how much is it now? In total? Where's your pocket calculators? What are you doing? How much is it? The expected value? Just multiply and add, please. Please. 11%. Okay, good. So it's 11%. Are we fine here?
Yes.
Huh? Good. So again, where are we? R is a continuous RV. How are we going to be describing it? We're going to be describing it probabilistically with a couple of statements. With a couple of what? With a couple of statements. The first is an expected value, which is what? Which is the most likely. The second is what? Is the square root of the variance. Is the square root of what? Of the variance. Now how much is the variance? So far we have defined the most likely value. We have defined what? The most likely value. So again, let's see this problem. You can expect to lose 10% with a probability of 10%. To break even with a probability of 20%. To gain 10% with a probability of 30%. Right? To gain 20% with a probability of 30%. And gain 30% with a probability of 10%. How much is the expected value? How much is the most likely R? The most likely R is 11%. You got it? So what you have is possibilities and the probabilities. What you have is what? Is possibilities and probabilities. Right? And based on what you have, you can solve for the most likely outcome. You can solve for what? You can solve for what? For the most likely outcome. I hope this is clear. Good. Let's go ahead and define the variance. So how are we going to be defining the variance? The variance is also an expected value. Is also what? But it's the expected value of a squared deviation from the mean. So again, so what the variance is about? What the variance is about? Why we need the variance in the first place? Why we need the variance? Why we need the variance? Because our second measure is about how far, right? Our second measure is about what? Is about how far. How far is sort of like variance. Sort of what, like what? Sort of like variance, right? So the second measure is about what? Is about how far. The first measure is about the most likely outcome, which we solved for, right? The second measure is about what? Is about how far are we on average from that most likely outcome. You got it? How far are we on average from that most likely outcome? And this is why we need the variance, right? So how we define the variance? How far is what? How far is what? How far from the most likely outcome? How far is the distance? The distance is a difference, right? Right? How far is what? In logic. How far is the distance? The distance is what? It's a difference, right? Right? So again, how far from where? From the most likely outcome. So our distance is going to be measured, is going to be benchmarked against what? Against that most likely outcome. And therefore, this is going to be my distance. This is going to be R minus the most likely outcome. How did I call it? How did I call it? How did I call it? The expected value of R. Right? So how much is this guy? What's the expected value of R? This is, what did I call it? This is what? This is the most likely outcome. And R minus the most likely outcome, this is how far. This is what, This is how far. It's a distance. You got it? So what, It's a distance. So we're not going to be working with the distance. We're going to be working with the square distance. Right? So this is the deviation from what? From the most likely, right? Right? This is the deviation from the most likely. And let me call it the mean, by the way. Let me call it what? Let me call it the mean. So let me call the most likely. Let me call the most likely value the mean. The what? The mean. Right? Now, how can we define the variance? Now, how can we define the variance? It's the expected value of what? Of a squared deviation from where? From the mean. From where? From the mean. You got it? You got it? So how do I define the variance now? It's what? It's the expected value of what? Of a say it in English, please. Say it in English. How did I define the variance? It's what? The expected value of squared deviation from the mean. You got it? Now the expected value of mathematics is what? The expected value is always what? How did I define the expected value here? It was the sum times what? It was the sum of what's expected times what? Times pi. Now let's do it again. How can I define the expected value here? It's going to be what? It's going to be the sum of what's expected times what? Times pi. You got it? So it's going to be the sum of what's expected, and what's expected? It's Ri minus the expected value of R squared times what? Thank you so much. Times what? Times pi, as I goes from where? From 1 to n, right? And in the problem we're solving now, how much is n? N is 5. How much is n? How much is n? How much is n? It's 1, 2, 3, 4, 5. So n is 5, right? 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 So now let me define the variance. How can I define the variance? Let me go ahead and define it and do it. So var R is going to be what? It's going to be what? Okay, so let's do it. We have what? Negative 10%, right? Right? Negative 10%, right? Minus what? Minus the expected value, minus the most likely, which is what? Which is 11%. What? Squared. Times what? Times pi. And pi here was how much? Pi was how much? Was 10%, right? So times what? 0.1, right? Right? Plus
The other one.
Plus, do it. So help me, please.
10%. 0%. 0%.
0
0%.
minus
11%.
11%
Squared.
squared times what?
0.2.
Times 0.2. Times what, huh?
0.2.
Plus
30% or 20%?
times what?
10%.
Times what? R here was how much? Was 10%,
10%.
right?
Yes.
10%
Minus 11.
minus
11%.
11%
Squared.
squared
3.
times what?
0.3.
Okay. Plus,
20%.
thank you.
20%.
Minus 11% squared.
Times 0.3 as well.
Times what?
0.3.
Plus.
30%.
Plus what, huh?
30%.
30%
Minus what?
minus 11% squared times what?
0.1.
Times what, huh?
0.1.
And this is going to be how much in total? Multiply and add and tell me how much. This is clear? Huh?
Plus 1 is square, right? 20% minus...
Please, just ask me smart questions. How much is it now in total? Of course, this is squared. But you know better, you know better. You can. Yeah. How much? How much in total? How much in total? Not sure. Double check it. How much, Khalid? Can I see it? 1.85%. Is it? This is true? I don't know. This is going to be 0. This is going to be 0.1%. This is going to be 0.3%. So it's going to be 0.4%. Can I see it? How much? Just give me the number, please. Okay, forget about the percentages. Just do 10 minus 11 to the power 2 times 0.1 and so on. And we can add the percentage sign at the end. How much is it going to be in total? How much? Did I give you a homework last week? Oh, you're going to be having homework this week. 1.29%? You sure? Is it squared?
I think
1.29%? Let me see here and double check it. I guess the answer, just hold this one here. How much is it? 2.7%, right? Is it? Okay, how much is it? Okay, 1.29%. 1.29%, right? Now, what else we can do here? Okay, so let me continue. So this is now the variance, which is what? Which is about the square deviation from the mean, right? Right? But my measure was about what? Was about how far? It was about the deviation, right? But I squared the deviation. So how can I possibly go back from the deviation square to just the deviation? I have to take what? I have to do what? I have to take the square root. I have to take what? I have to take the square root. Good. So the square root here, the square root of var r, this is what? This is the standard deviation of r, which is going to be what? Which is going to be the square root of how much?
1.29.
1.29, right? And the answer is going to be what? One point what?
1.135.
Okay, we're going to be having this much. So this is going to be what? This is going to be the standard deviation. This is going to be our measure of how far on average. This is going to be our measure of what? Of how far on average. You got it? Because how did I put it? My measure of how far on average. How did I put it? My measure of how far on average. How did I put it? How did I put it? I put it in terms of the square root of r. I put it in terms of what? In terms of the square root of r. Now I have r. I take the square root of it, and I'm going to be going home with what? With how far? Why I'm taking the square root? Look at it. Why I'm taking the square root? Because var r is based on what? Is based on how far squared. How far what? How far squared. The variance is based on what? The variance is based on what? The variance is based on how far squared. So in order to go from how far squared to just how far, what would you? I take the square root. I take what? I take the square root. Okay. I take the square root. In fact, when you take the square root of the variance, you're gonna be solving for the standard deviation of r. And this is exactly what I refer to as volatility or total risk in finance. You got it? This is what I refer to as what? Volatility or what? Or total risk in finance. Or what? Or total risk in finance. This is exactly how I refer to volatility, or this is exactly how I refer to as volatility or total risk in finance. You got it? Or total risk in finance. So let's review. So again, R is what? What's R? R is a continuous RV. How are we going to be describing it? We're going to be describing it probabilistically. With how many statements? Two statements. The first statement is what is the most likely statement. The second statement is what is how far on average. Is how far on what? How are we going to be solving for how far on average? First, we have to solve for how far squared, and then what? And then take the square root, and then take what? And then take the square root. So again, R is a continuous RV. We're going to be thinking of it probabilistically. How are we going to be thinking of it probabilistically? With a couple of statements. The first statement is about the most likely. This is what we refer to as the mean, the expected value. The second statement is what? Is how far on average. How are we going to be thinking of how far on average? We're going to be thinking of how far squared. And then after we're done, we take care of what? We take care of that square by taking the square root, right? So by taking the square root, you're going to be solving for the standard deviation of return, which is what we refer to as what? Volatility or total risk. Or what? Or total risk. So what is total risk in finance? What is volatility in finance? It's what? It's sigma R. It's the standard deviation of R. It is what? It is the standard deviation of R. You got it? So what's volatility in finance? What's volatility in finance? What's the standard deviation? Yeah, it's the standard deviation of R. What is volatility? What is risk in finance? It is the standard deviation of R. It is the measure of how far on average. It is the measure of what? Of how far on average. It is the measure of what? How far on average. How are we going to be getting here? How are we going to be answering to the how far on average? First, we have to go through how far squared. And then what? And then take the square root. And then take what? And then take the square root. How far squared is what we refer to as what? The variance. Right? And when you take the square root of that, you're going to be solving for volatility, which is what? Which is the standard deviation of return. Questions? Any questions? So I hope this is clear. Okay, and so again, total risk is what in finance?
Volatility.
It's volatility, right? And now let's define it. So let's define volatility. This is what? This is the square root of what? Of VAR, right? And what's VAR? It's what? It's what? It's the square root of what? Of the expected value of what? Of R minus the expected value of R, squared, right? And the expected value is always going to be what? Is always going to be a sum of what? Of this much times what? Times pi, as I goes from where? As O goes from 1 to n. As I goes from 1 to n. You got it? You see what I'm driving at? So again, risk in finance, what is it? What is it? It is the volatility of R, i.e. the standard deviation of R. How we think of it? It's a measure of how far on average, right? How are we going to be getting there? First, we have to stop at how far squared. And once we're there, we're going to be taking what? We're going to be taking the square root. We're going to be taking what? We're going to be taking the square root, right? Okay, good. Why we have to stop here? Why we have to go through the how far squared first? Why we have to go why we have to go through the how far squared first is because if you just sum how far, you're going to be ending up with 0. You're going to be ending up with what? With 0. If you sum up all the distances, from the mean, you're going to be ending up with what? You're going to be ending up with 0. You're going to be ending up with what? With 0. So how can we possibly correct for this problem? We're going to be thinking in terms of what? Of how far squared. So we're going to be thinking in terms of the distance squared. And then after we're done, we take care what? We take care of that square by taking what? By taking the square root. By taking what? By taking the square root. So I hope this is clear. Let me continue with the problem. Let me continue now with the problem. Okay, let's go ahead and do the second problem. So we have done the first requirement of the first problem. Don't worry about the second requirement for now. Let's go ahead and do the second problem. So what we have in the second problem, read the second problem carefully. Read it and tell me how we think of it. How we think of the second problem. How we think of the second problem. What we have, the second problem here, the second problem from above. The second problem from above, yeah. So this is going to be what? We have a beta of what?
1.45.
Okay, so we have a Sorbonne Industries, and they have a beta of what? Of 1.45, right? So beta S is what? 1.45, right? What else?
And risk-free rate.
RF is how much?
8%.
Expected return.
And R,
Expected return.
R what? Expected return on what?
13%.
Expected return on the market portfolio. So RM. RM is how much?
13%.
RM is what?
13.
13%, right?
Yes.
Right?
Yeah.
Now, how much is RS? How much is RS?
8%.
How much is RS?
10%.
13.
13.
Solve it. How much is RS? Solve it, otherwise I'll have to mark everybody down. Solve it. What should I do? Here, RS is going to be how much?
8%.
Huh?
8%.
What are you doing?
8. Yes, 8%.
8
8%.
plus what?
Market for
Plus what? Beta is how much?
1.45.
Plus what? Times what?
times portfolio is 13. 13.
What else? What else? That's it? You sure?
No.
It's like if we're not broadcasting, I would have said something. But we're broadcasting. Minus what?
Minus maybe 2.
Minus what?
Minus 8.
Minus 8%, of course.
Minus 8.
Why this is so?
This is how.
What finance is about? I'm very disappointed. I'm very, very disappointed.
This is like a market price.
Because I'm very, very disappointed. You have it here. You just can't. So I don't know. I don't know how you guys are here. Sorry. So this is how much? Don't make me wait for an hour, please. Just we're going to be multiplying and adding. How much I made?
15.25.
15 point what? 15 point?
25.
You sure?
52.
It's 8 plus. I can do it. It's 5.45. So it's going to be 5.
Doctor, 1.1525.
15.25.
Okay.
1.525.
Okay, good. So 15.25.
15.25 point.
Thank you. Good. Okay, good. Let's continue. Why this is difficult, huh?
It's not difficult. We answer.
So what else? So okay. So go ahead and solve B, the second requirement. Now you can do it. You can do the second requirement. So you can do the second requirement. Please tell me about the second requirement. So what we have from the first requirement? What we have from the first requirement? This is how much? This is how much here?
15.
It's R. It's what? Huh? It's R. So read the second requirement and tell me how we think of it. How we think of it.
Assuming
The second requirement. How we think of it. What we have? What we have? What we have? What we have? Tell me what we have. What we have?
required return revenue.
What we have R. We have R from the first requirement, and this is how much? 15.25. Okay.
Asking for price.
Then we have D0. Remember? D0 is how much? D0 is how much? It's $2, right? Read the problem.
Yeah.
Tell me why D0 is $2. Tell me why. Tell me why. Can you see that, Mansoor? Or still my thing is different from the book? Because it's the same now as the book.
Because it's a best price.
So can you see now, Mansoor, why D0 is true? Good. So what else?
This is a price per share. $2.
What else? What else we have? Read the problem. What else we have?
10%.
We have what? 10% is what? It's G. It's what? Huh? What's growth in finance? This is the first time you hear of it? Haven't you seen it before? Huh? What is it? How much is it? So G is what?
10%.
And now P0 is how much? Do it. Solve it. You can solve it. Tell me what to do. How much you study for this course at home? How much? How much time you put up for this course? 0 time. You're not studying at all for this course.
2 multiplied by
Yes.
10%.
Yes. So how are we going to be getting to P0? Which model?
P0.
Which model? Which model? Tell me about the model. Which model?
Finance.
It's the Gordon growth. Which model? Gordon growth. I'm marking you all down in attendance and participation. I'm marking you all down. You're not participating at all. You're not studying for this course at all. So good luck. So how can I solve for P0? It's what? It's a Gordon growth. It's what? You heard of it before? So what does it tell us, Gordon growth? Gordon growth, what does it tell us? P0 equals what? Equals D0 times what? Times 1 plus G over R minus what? Minus G. Come on, right? So now how much is it? See Khaled, Gordon growth? See Khaled, Gordon growth, Khaled? So tell me now what should I do?
2 times.
1 plus 10%.
Times what?
1.1.
1.1 over?
Over 0.0125.
Over 10% minus, over what? I'm sorry, over R. R is how much? 15.
15.25%.
15.25 minus what?
10%.
Minus 10%. And the answer is going to be what? And P0 is going to be what? P0 is going to be what? 2.2 over 5.25.
41.90.
Thank you. No. I'm very disappointed. No. You're not. You're just. No. Very, very disappointing. Not this much in this course. Not after this much. Well, yeah, I am very disappointed. So what about C? No, I'm very, very disappointed. What about C? You had enough of my positive energy. Until you told me we're going to be taking care of each other. So now into my negative energy. So now see what we do?
The beta will change.
See what we do?
Beta 0.80 beta first.
See what we do?
I have to get the
Okay.